This is the first in a short series of videos on GCSE Venn diagram questions. We're starting with drawing Venn diagram questions where you start with a paragraph like this and the first part of the question will be draw a Venn diagram. That first part won't always be there. Sometimes they will just ask you these parts and it's up to you to realise that a Venn diagram is a good tool to use. Now you can solve these questions without needing to know anything about set notation really. If you've ever seen a Venn diagram before, some intuition and a bit of experience will solve these questions for you. If you've never seen a Venn diagram before, this is what one looks like. In this question, 150 planes are flying to and from Heathrow and were surveyed, and we were interested in where they were going and whether they're on time. So we've got planes flying to Europe, we've got planes that are delayed, and we've got planes that are delayed and flying to Europe. So what we're going to do is this. The bit that people always or often miss out is just a big rectangle. That represents all of the planes, 150 planes. Then we've got two options. We've got planes that are flying to Europe, so we draw a circle to represent those. We've got planes that are delayed, so we draw a big circle to represent those. And this overlap here would represent planes which are delayed and flying to Europe. So the good bit of advice here is start with the most overlapping part of the diagram. Okay, so if you're making notes, start with most overlapping part. Now, you can't always guarantee that that will be the best way forward, but mostly 9 times out of 10, that's going to get you to the answer quickest. So this bit here represents planes that are going to Europe and which are delayed. So let's go through our question. 30 planes were both late and flying to Europe. So that is a 30 in there. And I'm going to cross that 30 off to show that we've dealt with that. Now, 43 planes were delayed. That means that this circle here has a total of 43 planes in it, but 30 of those planes are in the overlap here. So that leaves 13. 30 plus 13 makes our 43. That's why this part here is 13. Look at this part of the diagram. This is the planes that are delayed. They're in the delayed circle, but they're outside of the Europe circle. So these 30 planes are going to Europe and are delayed. These 13 planes were delayed, but were not going to Europe. Dealt with that 43, we'll cross that off. 81 planes were flying to Europe, so 81 planes are in this circle. 30 are delayed, that leaves 51 that were not delayed. 81 take away 30 gives us that 51. We've got 150 planes in total, and all those planes aren't represented by these. If I add those up, I've got 51, 30 and 13. Oh, I've dealt with that 81, I'll cross that off. Add those up, we've got 4, 5 and 3 is 8 and 1 is 9. So that's only 94 planes. So where are the rest of them? Well, the rest of them are outside here. They're not in the Europe circle. They're not in the delayed circle. They weren't going to Europe. They weren't delayed. They were some other planes. So that leaves 56 planes to be elsewhere in the diagram. Okay? So draw the diagram. Start by filling in the most overlapping part and work outwards. That's a rule of thumb. It worked nicely for us this time. We'll see in the next example that it's a good place to start, but won't always get you all the way to the end of the diagram. So, part A done. How many planes were delayed? Well, 43 planes were delayed, and actually that's a bit of a silly question because it does tell us in the question 43 planes were delayed, but we can see from the diagram, look, the ones that are delayed are these 30 and these 13. So 43 planes in total were delayed. How many planes were not flying to Europe? We've worked that out. Oh no, we haven't worked that out. How many planes were not flying to Europe? Well, these 51 and these 30 are flying to Europe. These 13 and these 56 are not. So 56, so for part B, 56 and 13, add those up, 69 planes not flying to Europe. Part C, how many planes were either delayed or flying to Europe? Well, these 51 planes, they fit that category, they were flying to Europe. These 13 planes, they were delayed, they fit the category. These 30 planes were both flying to Europe and were delayed. Now in maths, if we say how many planes were in this category or this category, we mean the overlap as well. So in maths, we're going to include that 30. Now in real life, if you said either flying to Europe or delayed, you might not mean that you want to count the ones that were flying to Europe and were delayed. But in maths, if I say either this or that, I'm including both, okay? So in real life, if you said, would you like tea or coffee? You're offering either tea or coffee. In maths, if you asked either tea or coffee, you're actually asking, would you like tea or coffee or both tea and coffee? That's the way we interpret that in mathematics. So those three categories. Now these 56 planes weren't flying to Europe because they're outside of this circle. They weren't delayed because they're outside of this circle. So we're not going to worry about those ones. So how many planes were either delayed or flying to Europe? Our answer is going to be 5 and 1 is 6 and 3, 94. And in fact, it's the same calculation we did already, wasn't it? So there's a Venn diagram with 2 circles in it. Last example. In this case, we have an activity centre with 90 teenagers, and they were doing various activities or they were not doing those activities. And if you read through, there's abseiling, cycling, and sailing are the 3 things that are involved. And then lots of details about who did what. So on our Venn diagram, we're going to need 3 circles. This is abseiling. This one can be cycling. This one can be sailing. And then we need to make sure the whole Venn diagram is in a rectangle. So for example, this area here represents everybody. It's in the abseiling circle, it's in the cycling circle, and it's in the sailing circle. So this area is everybody who did all 3 activities. This part here is in the abseiling circle, it's in the cycling circle, but it's not in the sailing circle. So this part of the diagram here is people that did abseiling and cycling, but not sailing. Now, rule of thumb I gave us on the last question, start with the most overlapping bit first. So if we can, we want to fill in this part first. So that is all 3 activities, and if we read through, 14 people did all 3 activities. So I'm going to cross off that 14, and it goes in there in the middle. Next most overlapping bits are these 3 bits here. This is 2 circles overlapping, 2 circles overlapping, and 2 circles overlapping. So let's see what we can fill in. 24 did sailing and cycling. So sailing and cycling is this bit. In that bit there are 24 students. 14 of them are there, so that leaves 10 for here. 20 did abseiling and cycling. So abseiling and cycling, this bit here is abseiling and cycling. 14 students in there, so there must be 6 students left over for there. 35 students did cycling, 9 did just abseiling. So the bit that we'd like to fill in now is this bit, the abseiling and sailing bit. But if we read the information that we've got left, we don't have enough information to fill in that most overlapping bit. That's why it's a rule of thumb. That's why it's not a hard and fast mathematical rule. It's helpful to start with the most overlapping part and work outwards. But sometimes the information that's given you in the question just doesn't work like that. It tells us 9 did just abseiling, and the just abseiling part is this part here. Okay, it's in the abseiling circle, but it's not in the cycling circle, it's not in the sailing circle. So we can fill in 9 there, and then it tells us 40 did abseiling altogether. So this circle here is the abseiling circle. So we've got 9, 6, and 14, and something gives us a total of 40. Okay, 9, 6, and 14 and something gives us a total of 40, and that something is going to go in here. Well, 6 and 14 is 20, add 9 is 29, so that something is going to be 11. Okay, so 9 did just abseiling, dealt with that one. 40 did abseiling altogether, so we just got these things left to deal with. 35 did cycling, so this cycling circle has 35 in it in total. So we're saying 6 plus 14 plus 10 plus something makes 35. So that leaves that something to be a 5. It tells us here 9 students did none of these activities, not abseiling, not cycling, nor sailing, so that gives us a 9 outside the circle. So we can finally fill in this part by adding up all these numbers, 9 plus 6 plus 5 plus 14 plus 11 plus 10 plus, I've got this 9, haven't I? 9 plus 6 plus 5 plus 14, 11, 10 and 9. Add all those up all together, and we know there are 90 students, because it says at the top 90 students. So all of that lot plus something makes 90, okay? And that something is going to be the missing part, which it turns out I think is 26. So how many students did exactly 2 activities? Well, that would be these students here, because these students are in 3 circles, they did 3 activities. These students, and these students are only in 1 circle, they did 1 activity each. So these ones are the ones that did exactly 2. So that's 6 plus 11 plus 10 gives us 27. How many students did sailing? Well, that is everybody inside the sailing circle, so that would be 26 plus 11 plus 14 plus 10. So add all those up, 26, 11, 14 and 10. So that's going to give us 11, 1, 2, 3, 4, 5, 6, 61. Unless I'm doing the arithmetic wrong, do check that. Now, what's the probability that a person chosen at random did not go abseiling? Well, how many people didn't go abseiling? That's everybody outside the abseiling circle. So that's 5 plus 10 plus 26 plus 9. So let's just work that out. 5, 10, 26 and 9. Add all those up, what have we got? Well, 5 and 6 is 11 and 9 is 20 and 50. So there's 50 students that did not go abseiling. And if we wanted to check that, we could just check that there are 40 students that did go abseiling. And in fact, it tells us in the question that there were 40 students that did go abseiling. So what's the probability that a person chosen at random did not go abseiling? Well, 50 students didn't go abseiling. There were 90 students altogether. So 50 students out of 90 didn't go abseiling. If you pick someone at random, the probability that they didn't go abseiling is 50 out of 90. Okay.